What if the next package you open simply disappears? Not recycled, not composted, but truly gone without a trace. No microplastics, no toxic residue, no damage left behind. Today, we're going behind the scenes of a revolutionary manufacturing process, one most people have never seen. A process quietly reshaping the future of packaging, engineering, and sustainability. This is the unseen world of biodegradable packaging. Plastic was once hailed as a miracle material, lightweight, durable, cheap. But decades later, that miracle has turned into a ticking bomb. By 2025, global plastic waste has reached levels never seen before, filling landfills, choking oceans, and entering the human food chain as microscopic particles. Every plastic wrapper, bottle, and package was designed to last for centuries, yet used for minutes. Recycling alone cannot keep up. Landfills are overflowing, oceans are becoming plastic reservoirs, and the environmental cost continues to rise. The world doesn't just need less plastic, it needs a completely different solution. The answer doesn't come from oil wells or chemical refineries, it comes from nature itself. Inside this factory, the raw materials are not fossil fuels, but renewable biological sources. Natural polymers extracted from plants, algae, and agricultural byproducts. Starch, cellulose, bio-based fibers. Materials that nature has been producing and breaking down for millions of years. What makes them revolutionary isn't just their origin, but how science has transformed them. Through advanced material engineering, these natural compounds are restructured at a molecular level, creating packaging that behaves like plastic but disappears like leaves on the forest floor. This is where biology meets precision engineering. Inside the manufacturing hall, automation takes over. Raw biomaterials are cleaned, refined, and fed into high-precision mixers. Temperature, pressure, and moisture are controlled down to the smallest unit. Here, material scientists don't just mix ingredients, they design behavior. The material must be strong enough to protect products, flexible enough to mold, stable enough for transport, yet fragile enough to break down after use. Advanced extrusion systems shape the material into sheets, films, and containers, with robotic molding machines form trays, boxes, and protective packaging with millimeter accuracy. Every stage is optimized for efficiency, minimal waste, and energy conservation. This isn't just manufacturing, it's engineering with a purpose. Unlike traditional plastic, this packaging is designed with an expiration date. But not printed on a label, it's built into the molecular structure. Inside climate-controlled chambers, samples undergo extreme testing: heat, cold, humidity, pressure. Sensors monitor strength, shelf life, and durability. Then comes the most critical test of all: biodegradation. In soil, water, and controlled natural environments, the material begins its final transformation. Microorganisms break it down into harmless organic components. No toxins, no microplastics, no residue. What once protected a product now returns safely to the earth. This is not greenwashing, this is true biodegradation, engineered, measured, and verified. One of the biggest misconceptions about sustainable packaging is that all bioplastics are the same. They're not. Some only break down under industrial composting. Some leave behind harmful fragments. Some are simply plastic with a green label. But this process changes the rules. Here, every stage, from raw material to disposal, is designed to work in harmony with nature's cycles. This packaging doesn't ask consumers to do more, it simply works. Used, disposed, gone. No sorting confusion, no complex recycling systems, no environmental debt. What you've seen today isn't a concept, it's already happening. Factories like this are quietly redefining how products are protected, shipped, and delivered without leaving a permanent scar on the planet. The future of manufacturing isn't louder machines or faster lines. It's smarter materials, cleaner processes, and engineering that respects the world it serves. The next time a package arrives at your door, it might not stay forever. And that's exactly the point.